better for our understanding to do reduction before special angles. Sorry, Jordan. Reduction formula. Well, formulae, because there's actually 4 of them. Okay, and we are 10.5, and today's Wednesday. Okay, so I'm just quickly going to remind you what I mean when I say cast diagram. A cast diagram is a Cartesian plane where I know which functions are positive and negative in which quadrants. So I'm literally just drawing a Cartesian plane. Okay. Still have my x and y in the normal places. Cast means that this 4th quadrant has cos positive, 1st quadrant has all 3 positive, 2nd quadrant has sine positive, and 3rd quadrant has tan positive. So that is what I mean by cast diagram. I know which functions are positive in which quadrants. But now when I talk about reduction formula, I'm still dealing with my Cartesian plane, but I'm also going to deal with those reference angles. So I'm talking about the fact that this is 90 degrees. This refers to 180 degrees, 270 degrees, and 360 degrees, or also 0, right? We've also seen that before. Now, because sine, cos, and tan are repetitive in nature, so you should know that from your second investigation, which also does not count for any mark. It repeats, right? So when you got those diagrams, you saw that your cos and sine repeated like little waves, right? You should have remembered that. And because it repeats, when we go around my Cartesian plane, there are repetitions in those angles. And the reduction formula allows us to find those repetitions. Okay? Which means when I have something like sine 36, it could be sine 36, but it could also be the repetition in the next quadrant. So we need to start knowing what those repetitions could be and write it down as part of my answer. So when I talk about repetitions, I'm talking about the fact that I have, let's say, 0,6 on my y. It hits over there on that graph, and it repeats and hits over there. So I need to find what that second angle's true value is, according to this reduction that I'm going to teach you now. And tan also repeats, but it repeats a little bit differently.
Now, can you explain it again?
I will. Okay, so reduction formula allows us to find the repetition of certain angles. And the reason why I'm talking about repetitions is because the function, the graph of these sine, cos, and tan is a repetitive graph. Okay? So if I'm talking about the fact that I have a y value of 0,6, I want to know all the x values where that occurs. So my x value where this hits, so let me just deal with one graph at a time here. Okay? I want to know where it hits every time that it hits 0,6. And I want to know those x values. But when we did the equations, our calculator only gave us 1, right? We only had 1 value. Here I have 4 values. My calculator is never going to give me all 4 values. But the reduction formula allows me to find what the other 3 values are by using the Cartesian plane, which is what we're going to do now. So because it repeats, there's going to be more than one answer. We need to find out what those other answers are. plane to do. Okay. So when I'm talking about, so that plane is different to this plane because my x values here are degrees, right? When you did the investigation, your x values were degrees. I wanted to know the degrees that would give me 0,6. The plane that I'm dealing with, the degrees go around the plane, not on a straight line. There it is on a straight line. 90, 180, 270, 360, on a straight line, right? They are all my degrees on the straight line. On this one, my degrees are not on the straight line. They go right around like a circle. So, ignore that for now because that's not what we're focusing on. We are focusing on how this reduces using the reduction formula. So if I wanted to do more than 360, remember we went 360 plus theta, right? And whatever that theta was the answer I used. Do you remember that? That is a reduction formula. That means we went all the way around to 360, and then we said 360 degrees plus theta. Now I'm going to teach you the other reductions that we could also use. And we saw that even though it was 540, if we put just the theta part into our calculator, we got exactly the same answer. That's because on the graph, okay, so 540, so here we have 180, 360, 540, no, sorry, 180, 92, yeah, this 360, sorry. So this would be 540, yes, sorry. And then double 360 would be 720. Okay, so we would have 360 to get to 540. Can you see how it would be the same y value as 180? Because it repeated itself. So now the same thing occurs when we have different reductions. If I have 180 as my reference, I can also go 180 plus theta. So I can go to 180 plus theta. It would fall into that quadrant, but I just have to know what theta is because it would repeat. Okay? So if I had 180 plus a little bit, it would be the same as, so if it was 240, right? Or let's say 200. 180 plus theta, what is the theta that I'm looking at? What gets me from 180 to 200? 20 degrees. So if I just find 20 degrees, it gives me the same y value. So instead of dealing with these very odd numbers, we deal with the reduction instead. So I'm going to show you what all the reductions are, and then we will practice it, and you'll see it's not so bad. So I can go to all the way around to 360 plus an additional theta. I can go to 180 plus an additional theta. I could technically go 170 plus an additional theta, but that doesn't match my repetition of my graph. Okay? So that's not an option. But what I can do is I can go negative theta, which we've already dealt with, in the opposite direction, or I could technically have called it 360 minus theta. So I went all the way to 360 and I doubled back. Now this one, I go to 180 and I double back. So it'll be 180 degrees minus theta. And those are all the reductions that I will deal with in grade 10. There are two more that relate to 90, but that's not a grade 10 issue. So that's the first thing you are writing down as quickly as possible. Is this CAST diagram with the reduction formula on it, please? So your first quadrant can either be positive theta or 360 plus theta. Your second quadrant, 180 minus theta. Your third quadrant is 180 plus theta. Your fourth quadrant is 360 minus theta or just negative theta. And the reason why I'm still putting this onto the CAST plane is that I can use the reduction formula, but I still need to keep CAST in mind because that still influences whether cos, sine, and tan are positive or negative. So this only gives me the value, but the quadrant tells me whether it's supposed to be positive or negative. So let's do an example. I'm going to take an example that we would reduce in each quadrant. So I'm going to draw a new plane. Okay. I'm going to give you 4 sine values that I want to put onto this plane. The first one I'm going to give you is sine 380 degrees. In which quadrant would sine 380 degrees be? Quadrant 1. 300 plus to 380, right? So for now, I'm going to write it into sine 380 degrees. Now I know that it is in quadrant 1. So is sine positive or negative? It has to be positive. Okay? Now I don't want to deal with sine 380. I want to deal with an acute angle, the smaller angles. So I can rather change this to sine 360 plus 20 degrees. I just used the reduction. Because the reduction in that quadrant is 360 plus the additional theta. We also know that in that quadrant, sine has to be positive. But instead of 360 plus theta, I'm just going to use theta. Theta is 20 degrees. So I reduced a rather big angle according to the positive or negative nature of my quadrant, into an acute angle. And what would that value be, Aaron? Just like that, sine 20, 0,34. Now what if I asked you for sine 160? Which quadrant would that be? Second quadrant. But I don't want to deal with a big angle. I want to deal with an acute angle. Using my reduction formulae, which is 180 minus theta, what is the theta here? What did I minus that would give me 160? 20 degrees. Now I need to check the positive and negative nature of sine. Is it positive or negative in the second quadrant? Check your class diagram. It's positive. What is positive sine 20? Well, we already calculated it, didn't we? It will be exactly the same, because of that repetitive nature of the graph. That is what causes it to be the same. So when I get an equation and I find that it is, I get told sine theta equals to 0,34, and my calculator will only give me the 20 degrees, but we just saw that it's the same in another quadrant. So we are then, after we've done the reduction, going to go back to our equations and check which other quadrant could it exist in. Let's try another one. Sine 340. Which quadrant? Quadrant 4. Use the reduction formula. Well, it's either going to be negative theta or 360 minus theta. I'm going to go with 360 minus theta. Because it is 90, 180, 270, 360.
Oh, so it's between 360 and 20.
What do I need to minus to go from 360 to 340? 20 degrees. Now, is sine positive or negative in this quadrant? So what do you think this answer is going to be? Negative 0,34. You see how just doing one of them allowed us to find all the different repetitions on the whole 360. So there's my positive repetitions. What do you think this is going to be? My negative repetitions, but the same value. So for instance, if I relate it back to that, there's my positive. (0,34). Okay. My negatives would be the same distance away, but in the negative version. So if I'm only doing 360, there's all four quadrants. Quadrant 1 is 90, right? 90, there's quadrant 1, 180, quadrant 2, quadrant 3, quadrant 4. Positive in quadrant 1 and 2, negative in quadrant 3 and 4. You see, so we are getting there. It's just taking time. So that is a function plane with the angles on the straight line. This is the cast plane with the angles at the points. But they do show the same thing.
But how come then it degrees is different to that degree.
What do you mean the
Or
degrees?
is it the same? Because, ma'am, you put 5 something, and in yours like 90, 180, 70.
Because the plane is different. So here I'm counting in 90, 180, 270, and 360 as the points on the x-axis.
Oh, okay.
But there it relates to 90, 180, 270, 360. It's two different planes. They're set up different ways. So the way we see it is different, even though it's the same information.
Okay.
So let's do the last one. Sine 200. Which quadrant? Obviously, I haven't asked quadrant 3 yet. What is my reduction? 180 what? Plus 20. Or plus theta, yes. Sine is negative in this quadrant. Sine 20 degrees, therefore negative 0,34. So if we just know what the acute angle is, we can find it in all 4 quadrants just by knowing one angle. So I could do this with any theta. Can be 20, can be 30, can be 400, they're not 400, an acute angle. So anything up to 90, and I can put it in every quadrant. So we're going to do one more, and then we're going to go back to our equations. Do we want to do cos or do we want to do tan? Okay, let's do cos. So you know what the reduction formula are now. I'm going to give it to you. I'm not going to tell you which quadrants or anything. I'm just going to give you the quadrants, the plane. I want you to place cos 150, cos 390, cos 210, and cos 330. Please place those 4 onto the correct quadrants and do the reduction formula and determine positive or negative and give me an answer. So I would suggest find the one where you start in quadrant 1 and do that one first. Yes, Courtney? 390. So find the one that puts you in quadrant 1 and start with that one. Yes, I'm very. If the angle is obviously less than 90, which in this case it is. Because, for instance, if it was 360 plus 110, then 110 is obviously here. But I'm keeping with acute angles, so yes, find the acute angle that places you there. Have we all? Okay, place them into the right quadrants. Or I'll just freeze. I'll freeze while I write. That's fine. Never mind. So I suggest you place them in the right quadrants, do each of their reduction formulas. Okay, so remember it's not the 150 minus 30. My reduction is always 180 minus. So you need to go 180 minus what gives me 150. So look at your reduction. That is what it must be, look like. 180 minus.
Oh, okay.
Okay, so I'll show you, for instance, I placed mine into the 4 quadrants. And now I'm going to do each reduction. So I'll do the first one. I know that the first quadrant must be 360 plus something. The second one should be cos 180 minus something. My third quadrant should be cos 180 plus, and my last one should be cos 360. Now you, I'm going to press freeze again, need to find out what is that needs to go in there. What acute angle will give me 150 if I'm minusing it from 180? Will give me 270 if I'm adding to 180, and will give me 330 if I'm minusing from 360. So what are those angles? They are all 30 degrees. Now the next thing I did was I checked according to my cast diagram what would cos be in each of those quadrants. First quadrant, positive. Second quadrant, negative. What do you mean it's wrong? Oh, yes, all the way around. Thank you. Okay. My second quadrant, cos is negative, then negative in the third as well, positive in the fourth. Okay? So the positive and negative nature comes from the cast diagram. So you always need to check the quadrants. And now only am I going to fill in the 30 degrees. Cos 30, cos 30, cos 30, cos 30. Can you see that this positive negative of the 30 is not the same positive negative that's in front of the cos? And that is the biggest mistake learners make. They think it's negative 30, so it's negative cos. That is a coincidence. Because look here, negative 30, but it is positive cos. And positive 30, but it is negative cos. So the sign comes from the cast diagram. So your positive and negative nature is from the cast diagram. Cos is always positive. That's what C stands for. All are always positive. That's what A stands for. S stands for sine is only positive. T stands for only tan positive. So if tan is positive only, it means sine and cos have to be negative. And if cos is only positive, then sine and tan have to be negative. That is what the cast diagram tells us. So that's part of the stuff that you've missed. Okay. Now I just need to find cos 30 once. Calculate. It's a special angle which we will learn, but cos 30 is square root 3 over 2, positive square root 3 over 2, negative square root 3 over 2, negative square root 3 over 2, and positive square root 3 over 2.
Ma'am,
Yes,
if I thought because 30 then it gives it me decimal.
because you have a sharp. So unfortunately for you, you are going to have to learn the special angles. Because our calculators give us the special ratio. Square root 3 of 2. Yes. No. When it's a special angle that gives you a full fraction, you use the fraction. If it's not a special angle, then you give the decimal. So if your calculator gives you a fraction, use the fraction. If your calculator gives you a decimal, use the decimal. Chardonnay, unfortunately, has extra work to do.
Ma'am, are you doing it wrong if it comes in your calculator?
No. No, but there are certain angles, 30, 60, 45, 90, 180, and 360, we call special angles, because they will always have a special ratio in a fraction form. Whereas everything else, so 44,6 for instance, would be a decimal.
But remember, we just write that
Then
down.
you just write whatever it is.
So we must know what those special angles
Yes. So if you know 30, 60, 45, you know those are the special angles, then you can just look up what the value is.
Okay.
So you just need to identify the special angle so that you can check the value. But we're going to do that tomorrow. So that's not too bad, right, grade 10s? We just have to know the reduction formula. Is it positive or negative? In which quadrant? So now let's go back to our equations. Okay, so we solved equations. Okay, equations. And here's one where we had to say, where it said solve for theta if theta is an element from 0 to 360 degrees. So that was our question. So example was a G. For instance, I tell you sine theta equals to positive 0,355. So is sine positive or is sine negative? It's positive, okay? Now in which quadrants is sine positive? 1 and 2. So I'm going to have two answers. Where sine will be positive 0,355. So now I need to find where is it positive. So we can find the theta, but we know that that's in quadrants 1 and 2. We know that it is positive in 1 and 2. How do we know that? A stands for all. S stands for sine only. So it's positive in both those two quadrants. Now, in quadrant 1, I can just do theta. Whatever the calculator says, I'm just going to do that. So I need to find the angle, so I'm pressing the shift 0.355. The angle is 20,79 degrees. So that's what the calculator would give you if you only looked at what we just did. And that's what we did yesterday. We only looked at one possible solution. But we all just agreed that sine can have 0,355 in quadrant 1 and because the question says in all 360 degrees, I need to find all the other options as well. There's another option, which is in quadrant 2, which is 180 minus. So quadrant 2 is going to be theta equals 180 degrees minus 20,79. So the angle in that quadrant that will give me the same value is 159,21 degrees. So this is called my reference angle. Just like the 30 was the reference when we did cos, and 20 was the reference when I did tan, in this quadrant, the reference is this question is 20,79. So if and you can check, sine 20,79 gives me 0,355, and sine 159.21 gives me 3,55. So we found both options of where it is positive. We will do another one. Anyone still writing this? Okay, not tan. Let's go cos. So 2 cos theta minus 1 equals to 0, and it is also 0 to 360 degrees. So just like we did yesterday, we're going to solve for cos theta. Okay, that's where we stopped yesterday. Yes. Oh, and that's not where we stopped yesterday. What we did then yesterday is we went theta equals to cos minus 1/2, and we found what that was. 60 degrees. Okay? That's where we ended yesterday, but we know more today. We need to check. Cos is positive in which quadrants? 1 and 4. Okay? So positive in 1 and 4. My reduction formula for 1 is just theta, so that would be my quadrant 1 answer. What is my reduction formula for quadrant 4? 360 minus theta. So I still need to do my 4th quadrant's answer. So that's quadrant 1. Quadrant 4 would be 360 minus 60. Or actually that would be my reference, okay? And then this would be 300 degrees. And check. Cos 60 gives me 1/2. Cos 300 also gives me 1/2. So we are checking in every quadrant because my question said between 0 and 360. If my question said between 0 and 180, would we have to do the 4th quadrant? No, because that's not part of my domain that I'm asking for. If I ask between 0 and 270, still no, because cos is positive and that's only in 1 and 4. What happens if I had asked, where is cos negative 1/2? Which quadrants would I have to calculate then? 2 and 4. So let's do one like that.
Why did you say 2 and 4?
Because you guys said 2 and 4. 2 and 3, yes. 2 and 3. Okay, so I want theta given that and in the domain of 0 to 270. So theta is an element of 0 to 270. First things first, cos theta equals negative 1/2. So my reference that I'm using, my reference angle would be cos negative would be 120 degrees. I'm looking for a negative cos. Cos is negative in which quadrants? 0 and, 60 degrees. You don't use the positive or negative, you only use the number. So it is in 2 and 3. So I'll say that again. When you check on your calculator, don't use the negative. The negative tells us the quadrant, not anything else. So the negative I'm using with 2 and 3. The reference angle is only using the number. So cos 1/2 equals to 60. So my reference angle is 60. Now I need to do the reduction in quadrant 2 and the reduction in quadrant 3. What is quadrant 2's reduction? 180 minus what my reference angle is. And what is my reduction in quadrant 3? 180 plus what my reference angle is, which is 60, So my true theta would be 120 degrees, or theta would be 240 degrees. If I did theta is an element of 0 to 180, would I have done the second calculation? No, because I would not have gone past my second quadrant. So we always need to check what it is. But the most common one is for me to ask the full plane, 0 to 360. So then you need to check all four. Okay, I think we have 4 more minutes, one more. But this time I'm actually going to let you do it on your own. We still have 4 minutes. Okay. Remember, we are top B wing. We have to wait a little bit longer. So we go. Please find theta for me. Okay, we're just finishing this and then we'll pack. Is sign positive or negative? Which quadrant is it positive? 1 and 2. What is my reduction for quadrant 1? It's just theta. What is my reduction for quadrant 2? 180 minus theta. So your answer should look like that. Positive in quadrant 1 and 2. The reference is 30. Quadrant 1 is just 30. And therefore 2 is 180 minus 30, 150 degrees. Okay, as soon as you've done that, tack up. Tomorrow we're going to move on